Vanakkam, Namaste, Namaskar. Today I'm going to take a small topic which is related to basic physics. Basically, I will call it physics fundamentals. Whether this topic is going to be useful for you in marine life or no, will just have a look and see, and you will yourself realize that am I using it in my subjects in navigation or not. Let me just quickly start. I mentioned is pressure fundamentals. So I'm going to just look at a very basic concept which actually is happening at home. Uh, it's not even anywhere else. You can see it at home. I'm going to give you a water tank. Let us say the water tank in your terrace, which is the topmost open floor on your building. I'm going to give two pipes of two different diameters. Let us say one is a 4 inch and the second one is a 1 inch pipe. And I want to discuss, or I want to ask you also, which pipe out of these two, if I put taps right at the ground floor, which one will give you more pressure? So I'm going to just, let us say this is the final place where a tap is there. Similarly on the 1 inch diameter one. And my question was based on pressure. So what I will do is I'll put a pressure gauge here and a pressure gauge here. And this is what is my question. So which of the two gauges will show me greater pressure, the 4 inch one or 1 inch pipeline? Majority of you will jump up to an answer. This is the bigger one, which is 4 inch pipe, because it looks very logical. That is what 80% of you will give me the answer. But you should realize the answer is no. Okay, it is not the 4 inch pipe. Now you'll be suddenly surprised and you will start thinking, okay, what else choice do I have? The only choice is 1 inch pipe. So next for you, the answer is 1 inch. If you honestly ask me, that answer is also no. It is not the 4 inch, not the 1 inch. And what is the answer? For that, I'll just quickly go into a small simplified formula. This formula is uh, similar to something called your potential energy in your physics. So I'm going to modify it a little bit because that is where you can realize whether I need this in your profession also or no. I'm going to quickly show you. Pressure can be given as a multiplication of the height of the liquid inside the pipeline and its density. Now here it's very evident. The water is coming from the same tank. So the density has to be same. And since it's coming from the same water tank also, the height also has to be same because I'm asking you at the ground floor. So the answer is both the pipes. Please remember both the pipes at the bottom. If I put two pressure gauges at the bottom of the ground floor, they'll have the same pressure. Okay, let us look at the principle behind it when I start showing you this future PPTs, the slides, you will get the answer. Okay, right now, this is what you should remember. Pressure is equal to height into density, height of that liquid. Now, liquid pressure, as I said, has to be same as far as your density is same as well as your height is same. So this is the result of your simple question. And this is what is happening to you at your home also. If you take two different pipes in your building, they will show you the same pressure. There's nothing different. But then what is the advantage of having a 4 inch pipe and a 1 inch pipe? Why somebody chooses a 4 inch pipe and why somebody chooses a 1 inch pipe? There's a reason for that. The reason is not the pressure, but the volume. Okay. It is the volume which I will try to take advantage of the 4 inch pipe. The amount of water coming out in the 4 inch pipe will be more than the 1 inch pipe. So why should I use it and where should I use it? So normally what happens is that in your flats, let us say you have some 10 floors, the pipe which comes immediately out of the water tank is always having a larger diameter, the larger size. Okay. Now, why is the larger size? Why? Because from that water tank, there's a lot of houses in these 10 floors which need water. So that means you will always deliver it with a larger pipe so that I can give it to more houses at the same time. But then what happens is, as and when the floor keeps coming down, you will see the diameter of the pipeline also may be reduced, because you don't need so much diameter as and when you start coming down, let us say on the fourth, the third, second, and the first. So your pipe diameter will start coming down so that you can get water enough, uh, because the main top floors are over now. So you are coming down. That is the principle of your pipes at home. So the number of houses keeps reducing as and when you come down. Now, the same concept can be used, the same pressure concept can be used in a different instrument somewhere. Again, it can be in your housing colony, or it can be in your ships also. What is that? Let us quickly see. There's a gauge glass. All of you, if you just walk out of your home, let us say you have a big overhead tank which is made for the whole colony. Usually, you'll see the Metro Water makes a whole huge water tank, and you will always see a gauge glass. The purpose of the gauge glass is to find out how much liquid is there inside that tank, because every time you're not going to go and open that uh, cover on top of that particular tank and go and watch. So, but there will be gauge glasses. So, how do these gauge glasses work? Now, a big tank can have a small diameter gauge glass. I'm just showing you. Let us say this is the big tank. It has got a water. I can't go and peep in, and I can't make it transparent. I can't make a big, huge concrete tank transparent. So what I'm going to do is I'm going to connect it with a small gauge glass. Okay, this gauge glass is going to be transparent. I don't need a big pipe also. Now, what is the principle behind this gauge glass? It again uses the same liquid head, and it uses the atmospheric pressure. You will see the atmospheric pressure which is acting on this tank or this gauge glass, both are same. It's the same atmospheric pressure. So what happens is, due to gravity also, this water enters this gauge glass, and you will have the same liquid head. Now you can see the atmospheric pressure is also same, and your liquid head pressure is also same on both the big tank as well as your gauge glass. So this is the advantage of keeping a small gauge glass, and I'm very sure you would have seen this thing, this kind of instruments or sight glass, which is there in many of the equipments on board also. Okay, so now let me just add one more. If you see our traditional masons who build your house, they don't have all this high-tech gadgets to check whether your levels are same. So they use a simple concept. They use a level tube, and they will pour in water, and that tube can be quite long also. So it can run from maybe one wall to the other wall also. So they will pour liquid, and they will see where the liquid is exactly at the same place. And that is how they make whether they have done the layers of the bricks, everything in the same level. So this is how it is used in a simple concept at home again. Now, the moment you have understood this concept of two different pipes, but they're having the same pressure, then a question will pop up immediately. This question is, then why do larger pipe, when you open the water, compared to a smaller pipe when you open the water, cannot give a longer jet? A larger pipe cannot give you a longer jet compared to a small pipe. I'll rephrase this question again. Let us say you have a garden hose, you open the water, and now you want to have a longer throw, or you want to hit that water, you want the water to hit your car or something with a little bit greater force, so that you can clean your car. So the best thing what you do is you always squeeze it. Now, moment you squeeze it, you will realize that I'm going to get a longer jet and little bit more concentrated with little bit more force also. Then how do you justify this with the principle which I've already told you when I told that a big pipe also and a small pipe also, they'll have the same pressure. How do you justify this? I think I will keep this for the part 2 of this concept. I've written as important concept. Why? Because it's quite useful. It's useful even in day-to-day life, and at the same time, also this concept is used on board also. So I will leave it for you to think about, and I'll come back with the next part of the same pressure fundamentals, and I'm going to give you that answer. Till then, we'll stop this topic here, and I'll catch you soon. I'll come back with your the answers, and I'll try to give you one more concept which is very similar and related to the same principle. So I'll catch you on part 2 of that. Until then, Vanakkam, Namaste, Namaskar.